All right, it's time for lab 2. This is vectors part 2. So we are adding on the big 3 to our vectors lab from last time. And so now it's finally going to be perfectly correct in terms of like not leaking memory, not doing weird stuff. All right. So yeah, we're going to overload the big 3, make them the right way. And this is a lab where you just have to get lab 1 working beforehand. You cannot pass this lab without having lab 1 working. All right. So please start early, ask me lots of questions. Make sure to finish lab 1 in time because this one just won't work without the right implementations of the old stuff. You'll copy all of those in, okay? So do start this a bit earlier and let me know if you have questions. So the starter code is you get it in the same exact way. You probably have it by now. You know what to do. You see the pattern. And so get the starter code. Here are all the files you'll see. And yeah, the first step is to like implement those big 3 things. So in vec.h, I showed you in lecture, the new ones are right in here, right? So in addition to your old stuff, which you can copy in, there won't be any difference. You're going to add on the implementations of these guys. And one thing that I didn't show you in class was this no except. So that's just you marking and promising to not throw an exception in the implementation of your of your copy assignment operator. So yeah, just keep that along for the ride. Treat it like a const almost. As long as you don't throw an exception, the compiler will be happy. This is just a common thing that people put on their copy assignment operators, and I want you to have seen it. So yeah, get that working in vec.cpp. And yeah, here's the new stuff. You'll bring those in. Whenever I give you code and say fix me, this is a line that's completely incorrect. All right, I just want you to say, I want you to notice that this will let it compile so you can work on other things. This line is completely wrong. Please delete it. It is not right at all. Okay. So just keep that in mind. This line is meant to be replaced. This is nothing useful to you. It's just letting it compile so you can work on other things. So yeah, this is the new stuff where you will work on the new things. And you can follow along with my slides from lecture, and these comments should be helpful. And then you'll paste in all of your old stuff from the last lab because all of those are still going to be the same. Okay, so yeah, this is the new stuff. Get those working in the ways that we talked about, and that should be that. So I've made you, again, a makefile and a testing program. Get those tests to pass. Just making sure that we can use the copy constructor and things have been copied properly. And like when I change the new stuff, it was a deep copy so that doesn't mess with the old pieces of the old one. Okay, making sure of those things. And yeah, testing copy assignment, etc., etc. So I've made those. And so get those passing, please, with the make test spec will compile and you can run in as usual. And then your job is to write 4 more tests in the same style. Like you do some weird combinations of copy constructors and copy assignments and whatever. Maybe make a vec on the heap or something, because then you could use delete and make sure that the destructor, I guess you can't check the heap memory went away, but you can still make your vec on the heap if you want to try that and mess around with it. And yeah, I just want to see 4 more tests. So please have 4 more tests passing in addition to my own. And that will be your changes to test vec. And yeah, you'll add those. So not a lot of things to say, as we talked about most of it in class. So get my test passing, add 4 more. And then the last thing I want to have you do is just like remember some CSCI 40 things, and then also use the fruits of your labor. Because like we've been making this vec class, and now it's finally perfect. Use it. So here's another program. It's called Calc Receipt. It's like meant to be a simulation of like one of those machines that you like somebody uses when they're like ringing you up at like a restaurant, or like you go to In-N-Out, let's say, and like they're ringing you up for whatever you ordered on at the front. And so this is going to calculate and print out your receipt maybe for a restaurant. And so yeah, this is a program that uses your library and does something kind of useful. So Calc Receipt, its job is to read a file that was passed in using command line arguments that tells you like what you ordered. So like it was somebody's order, and we will extract the prices from that file, sort them, and print them and their sum to the screen. So it's like you're writing a pretty receipt for somebody, like pretend that got output on a piece of paper for them. And so yeah, here's kind of what I want you to be able to do. So I'm using command line arguments, by the way. This is using argc and argv. Go look that up if you haven't seen it before. It's something we teach in our CSCI 40 class. And here I am making an ifstream object that's going to read from that file name. So it's like I've passed a file name on the terminal. This is argv of 1. That'll hold whatever I type there after the name of the program. That's how I get that. So yeah, that's what command line arguments give us. They let us do that, and I've already done it for you. I've started reading that file, so I've made the file object as an ifstream. This is reminding you how to use ifstreams as well. And then I'm making a vector of prices, and the goal is to take that file that was formatted as a CSV file, which is short for comma-separated values. And so a CSV file looks like this. It's just a bunch of lines with a bunch of commas separating things. Like it looks like what I've made these CSV files to be, and this is what you can assume. It's always going to be name of thing, price of thing. Name of thing, comma, price of thing. Name of thing, comma, price of thing. So your job is to forget about their names. So there's order 1. Here's order 2. All right, just interesting things in terms of integer values, which are cent values. That's fine. So yeah, this is like me going in and out. And yeah, your job is to extract these numbers after each comma. So that's what you'll remember how to use ifstreams to do that. Okay, so here I am reading every line of the file. So inside of this loop, I'm getting a new line of the file into this variable called current line. So that's me using the ifstream to read. So I've already done that for you. Just fill in the body. All right. So each time we're in the body here, we've got a new line set into current line. And I want you to take the price out of this line, convert it to an integer, and push it back to this prices vector. All right. So you'll have to use like find and subster and s2i to convert a string to an integer. Go look into those library functions. Okay. That will help you get on the right path. Oops. And again, you're reading into this file. It's in IFS, and each current line is a new line of one of these CSV files that you're starting to read. So like the very first line is this one. The next line, IFS is current line is set to this. The next line, current line is set to this. So your job is to find where that comma is, because everything until the end of the line is a number. Extract it, convert it to a number, put it in the vector. Does that make sense? So you're finally using your vector to do something cool, rather than just like checking that it holds integers, like actually doing something with them. It's great. And then your job is to sort the prices, print them out with a $sign at the front, and convert those numbers, because they're going to be in cents. Convert them to dollars and cents. So add a decimal, get the dollar amount, get the cents amounts, make them nice. And then, so you'll sort your vector using the sort method. That will let you like iterate through properly and print things out properly. And then you'll also want to find the total, just add them all up, and again, print them out with a $sign and a dot. And you want to print that total out after a line with exactly 6 dashes. Okay, so that's the job. This is what it should look like. This is exactly what your output should look like for the order.csv file. And something similar happens for order 2. Okay, so yeah, that's that one. That's calc receipt. And I think that will help you. This is one way to print the cents correctly. You can do set W and set fill if you try to extract things, but there are other ways to do this. This is one way to do it. So ask me if you're having any trouble, but this is you finally using the vec to do something. And we're remembering how to read from files too with IFS, with ifstreams. So yeah, use this program to read a file line by line, extract the numbers as prices, sort them, print them out in a pretty way in addition to their total. All right, so that's the calc receipt program that you'll fix and make right. And it's make calc receipt to compile that, and to run it, you're going to say /calc receipt space the name of the file you want to open, and we're getting it into this ifstream object called IFS, and argv1 is holding the name of that file. That's how we get it. All right, and that's what these things are for. They're called command line arguments if you haven't seen them before. All right, and I think that's what I wanted to say. Yeah, look into S2I to convert strings to integers. It's going to be like .find on a string to figure out where the comma is in that CSV file line. And I think that's all I can say. Come to office hours, yell at me, ask me any questions that you need to, but get that working too. And that's the last part of your lab. So the things that you'll be turning in are going to be the final implementation of the vec class that has the big three properly, the test vec file, because you're going to add 4 more tests, and then calc receipt is a file that actually uses your vec library finally and does something cool with it, and you filled that in to work properly. Okay, so that's what you're turning in. Remember that your last submission is your grade, and watch that due date. And I think that's what I wanted to say. So let me know if you have any questions about anything, and I will see you in the next one.